Let's solve for this logarithmic equation here. So we have log of x plus 6 equals to log of x plus 2 equals to log of x plus 20. All right? So here, whenever you look at these equations, you always see if you have anything to combine together to make it as a common one log by using the log property. Okay? So in this case, we have two of them. We have addition. So because of the addition, what's going to happen? We're going to use the product property, right? So that would give us what? So that would take us to log then of x plus 6 times x plus 2. And that would be equal to log of x plus 20. Then we can put brackets around this one to make it look nice, okay? So then, what can we do now? What do we see? We see that we have a log on the left side. We see we have a log on the right side. We can drop them, right? So that's the beauty about this problem. So these are dropped. So what's happening? So we have x plus 6 then times x plus 2. And that is equal to what? X plus 20. Okay? But once we have that, so what's going to happen now? So now we can use the FOIL method to expand this one here. So the first, that is x by x, is x to the second power. The outer, x times 2, which is plus 2x. The inner, 6 times x, which is plus 6x. The last, which is 6 times 2, which is 12. So we got that. That is equal to what? X plus 20. Okay, now we got to combine like terms. So we go to the left side of the equal sign, combine like terms there, and then afterwards, when we still have like terms in the equation, we got to put them all together, right? So first, we go in here. So that would give us what? X squared plus 8x plus 12 equals to what? X plus 20. And then we have x in common with 8x. We got to put them together by doing what? Negative x both sides. This is out. We end up with x squared plus 7x plus 12 equals to what? 20. Now we're not finished. So what's happening here? So we got to do negative 20 both sides. This is out. And then x squared plus 7x. And then positive 12 minus 20 is going to give us what? So both of them, one carries negative, the other one carries positive. What can we do? So we have to what? We got to subtract to keep the sign of the highest number. So 12 take away from 20, that is 8. And then negative 8. Because you keep the sign of the highest number, this is it. So you end up with x squared plus 7x minus 8 equals to 0, which is a quadratic equation. But because we have a quadratic equation, what can we do with it, right? So either we can use the quadratic formula to solve for it, or we can factor this expression here before we can do it, okay? So in this case, we're going to factor it, okay? It doesn't matter which one you like, which one is easier, or which one is asked for, okay? So let's go for it. So in this case, the good news is that A equals to what? Is 1, B equals to positive 7, and C equals to negative 8. So we have this, right? That we can carry with us and then work with. So what's happening is that we're going to use the AC method to factor it. So that means A, which is 1, and then C, which is negative 8, right? So we multiply these two together, that gives you negative 8. So you're looking for two numbers. When you multiply those two numbers, you end up with negative 8. When you add those same two numbers, you add up with 7, right? So what would be those two numbers? So if we take 2 and 4, would it work? No, because 2 and 4, you can never add or subtract to give you 7. Never. But of course, you can multiply to give you 8, but you need to fulfill those two conditions. 1 and 8. Yes. So 1 and 8, 1 times 8 is 8. And how now can you add or even multiply, first of all, to give you negative 8? One got to be a positive, the other one got to be a negative. But you got to get positive 7. Because if this were to be negative 8, when you add them up, you're going to get negative 7. You don't want that. Okay, so negative 1 is good. Because negative 1 times 8 is negative 8. Negative 1 plus 8 is 7. We good? All right, so let's go. So once we get that, we're pretty much done with that. So that means we have then x minus 1 times x plus 8 equals to 0. And from there now, we can solve for each of them, right? So that means we're going for x minus 1 equals to 0, or x plus 8 equals to 0. So that means x equals to 1, right? And then we have x equals to negative 8. So these are the two potential answers, but they are not definite answers in this case. We've got to check them out and see what's happening. So let's say we check when x equals to negative 8. Okay, we do that. So that means we go back to the original equation and then we plug negative 8 in there. So it's log of negative 8 plus 6 plus log of negative 8 plus 2 equals to log of negative 8 plus 20. Okay? So once we get that, what's happening now? So we have log of negative 8 plus 6 is going to give us what? Negative 2. Plus log of negative 8 plus 2 is going to give us what? Negative 6 equals to log of positive 12. Now what do we see here? Log of negative 2, we can't do it, okay? By log properties. We cannot have a negative sign of log. Same thing as log of negative 8. So because this doesn't exist, this doesn't exist, we add the two of them, it's not going to exist still. So what's happening? This is not equal to. Even though this one is going to exist, right? Because log of 12 is going to give us an answer, okay? Some decimal number, but these two does not exist, so it's not equal to. So that means what? So that means x minus 8 is not a definite answer for our problem here. Then you got to check it for x equals to 1 as well to see what's going to happen. Okay? So you guys now are asked to do that. Okay? So you got to check when x equals to 1 what you're going to get. Okay? So you got to check this. So this is for you to find out. Okay? Thank you.